Hey, what's up, guys? I think I'll do a quick run through of the STAAR test from 2015. This is for Algebra 1. So we're looking at the STAAR Algebra 1 test administered in May 2015. So let's go ahead and run through this and see if we can see anything. I want to show you some calculator techniques to get through the test here that might be useful. So let's go have a look. Alright, so we're looking at the first question here. Alrighty, and I can't see it all, so I'm going to zoom out this way. Alright. And the first question here, it says a scatter plot shows a number of visitors to a beach each day and the high temperature in degrees Fahrenheit for that day. Alright, so let's get this pen working here. As you can see here, we have temperature on the bottom and the number of visitors right here. Keep in mind, it's worth noting, this is the independent variable. That's always what the x variable is. It's independent. And the dependent variable is the number of visitors. So as we typically say, y depends on x. Whatever this variable depends on this variable. So it says here, based on the scatter plot, which statement appears to be true? There is a nonlinear correlation between the high temperature and the number of visitors on the beach. Well, I don't really think that's true. If you look at these points, they kind of follow a linear pattern. You can sort of draw a line through most of them, where some of them are on top and some of them are on bottom. This is fairly a linear pattern, so I'm going to say that's not true. Okay, I'm looking for the one that is true. I say that is actually kind of a linear pattern. B says when the high temperature is above 100 degrees Fahrenheit, fewer than 150 visitors are expected on the beach. So it does, as you notice, that the temperature doesn't actually go much further. Right here at the very end, that would be 100 because they're going up by 5s. 95, 100. But at 100, if I follow kind of where this line was, I'm expecting basically a turnout like this. So I'm going to trace from 100 and trace back over here, and I'm going to expect something around 240 or 210, somewhere thereabouts. Definitely more than 150. This says fewer than 150, but I'm going to say, that 240 is not fewer than 150, so this is wrong. It says there's no correlation between the high temperature and the visitors on the beach. So this answer says there's actually no relationship between temperature and visitors. It's pretty common sense. If the temperature is increasing, you can see that the visitors are kind of going up gradually. So that doesn't make any sense. There is a relationship. There is a correlation. So this leaves the last answer. When the high temperature is between 75 and 90, then I'm expecting more than 120 visitors. So here's 75. Okay, so we'll go up to my line. And 90, that's the second temperature they give me. So 90. And I'm going to come over here. So I'm expecting somewhere between 120 and maybe like 180 people. And I'm expecting more than 120. That's true. Between 120 and 80, I'm expecting somewhere in this ballpark of number of people. So definitely more than 120 right here. Somewhere between 120 and 180-ish. So this is actually the only reasonable answer that you really have. So the answer is D. Alright, number 2. Let's actually zoom in on this. This is actually kind of a tricky question. A man bought X boxes of donuts for $3.49 each. He paid with a $50 bill and received the correct amount of change. If he received more than $10 but less than $20, which inequality represents the number of boxes of donuts he could have bought? I want you to keep in mind here that X represents the number of boxes. Each box cost $3.49. Okay, so it's $3.49 per box. That's how much you're paying. $3.49X. This guy's paying with a $50 bill. So he pays $50. So that's what he gives the clerk. The clerk will keep the money owed to him, which is $3.49 per box. And then whatever's left, $50 minus what the clerk keeps, is what change he gets back. So this is equal to something. This amount, though, is somewhere between 10 and 20. So he receives more than 10 but less than 20. So what I actually have is an inequality here. All right, so this amount here is actually going to be just erase that. Where's my eraser? Okay, a man bought X boxes of donuts for $3.49 each. He paid with a $50 bill and received the correct amount of change. If he received more than $10 but less than $20, which inequality represents the number of boxes of donuts he could have bought? Alright, so you're talking about the number of boxes of donuts. This is X. This is the number of boxes. You have X boxes of donuts. This is what he's paying for each box, $3.49. So logically, $3.49 is being multiplied by the number of boxes. It's $3.49 per box, and this is the number of boxes he's taking, right? He's paying with a $50 bill, so this is how much he gives the clerk, all right? The cashier, $50, and the clerk will keep whatever's owed him, which is what? $3.49 times the number of boxes that the guy bought, all right? And whatever's left is going to be the change from this. This change that he's getting is somewhere between 10 and 20. It's more than 10 and less than 20. All right, so what I'm going to actually come out and say is that this is the change. It's $50 minus what the clerk keeps. So this is the amount of change this guy's keeping. This value is going to be greater than, this is going to be greater than his $10, but it's going to be less than $20. So the amount of change is between 10 and 20. That's what it says here. Okay. So now what I'm going to do is basically solve this equation for x. There's actually two equations here. All right, so let's solve this for x, and what I'm going to do is subtract 50. Try to get x by itself, I have to get rid of this and get rid of this. So I'm going to subtract 50 from every side, both the left side and the right side and the middle. Take 50 away, this is going to be 0. 10 minus 50 is negative 40. And 20 minus 50 is negative 30. So let's consolidate what we have here. On the left side we have negative 40. In the middle we have this left over. So don't forget this inequality. We got 349x, and then we have less than negative 30. Now the idea is to find x, okay? So I'm going to have to get rid of this. This is x times 3, negative 349. The opposite of multiplying is to divide. So to get x by itself, I have to divide this by negative 349, this by negative 349, and this side by negative 349. It is worth noting that a negative divided by a negative is a positive, okay? So all of these will be positive. But because I divided by a negative, these inequalities, both signs here, need to be flipped over. So this is going to turn this way, and this one's going to turn this way. And what I'm going to have here, this is going to cancel out here. All I have is x in the middle. So x is going to be between something and something else. So let's figure out what negative 40 divided by negative 3.49 is, and negative 30 divided by negative 3.49. So I'm going to make the calculator do that for me. All right. So I have a trusty dusty calculator. I'm going to open up a calculator window, and I'm going to say divide. So control divide. I need to figure out what negative 40 divided by 349 is. I'm sorry, negative 349. Let's make that a negative. Don't forget that. Do it just as it says. That's going to be $11.46, somewhere thereabouts. For the other one, it's going to be negative 30. Let's do a control divide again. Control divide will give you that nice little fraction. So this is going to be on top here, negative 30 divided by negative 3.49. And that'll be $8.60, we'll say. So 11.46 and 8.60. These are my lower and upper boundaries here. So 11.46 and 8.60. Let's go back to the problem. All right, so this is going to be 11.46, and this is going to be 8.60. So what I'm declaring then is that x is actually greater than 8.60, but it's going to be less than 11.46. All right, so another way of writing this is to say that 8.60 is less than x, which is less than x, and x is less than 11.46. So let's check these answers out, see if anything looks like this. If x is greater than 8.60, then it definitely could be 9. It could also be greater, x can be greater than 8 as well. So this is all fine for every one of these, okay? But where we're going to have a problem here is that x has to be less than 1146. All right, well, 11 is in fact less than 1146, but 12 is not. 12 is not less than 1146, so we can actually say this is correct. We have to get rid of the answers with the 12 maximum. So we're looking at this and this. All right, now keep in mind that x has to be greater than 860. All right, and we have to choose between this answer and this answer. The reason I can't choose 8 is because the value between 8 and 860 is like 820. Okay, if I choose this here, it means x could actually equal 820, but that's not true because x has to be actually greater than 860. So this is actually not correct. The answer that only answer really makes sense now is F. This is a kind of a challenging question. I'm not going to lie. It's not one of my favorites there, but the answer is F for that one. That's a definitely intermediate to difficult question. Let's come down to number 3. This one's a little simpler. In fact, this is very simple. You'll have some easy questions on this test, and you'll have some challenging questions on this test here. So let me move this out of the way. It says the graph of a quadratic function R is shown on the grid. The quadratic function, as you well know, makes a parabola. That's what this U shape is called. It's called the parabola. They're saying what is a solution to the graph equaling 0? All right, this graph will equal 0 on the x-axis. Wherever this graph crosses the x-axis, that's where it is equal to 0. That's where the y value is 0. So I have a coordinate here and a coordinate here. This coordinate is -6, 0, and this coordinate right here is 14, 0. So the y value, this is the same thing as the y value. The y value is equal to 0 here and here, and they don't want to know what the solution is, so they're asking you for the x value. This x value is -6, this x value is 14. Which one of these two values is a solution? The answer is 14, because -6 is actually not in our answer selection. So that's the answer for this question, number 3. All right, let's move on. Okay, number 4, the function y equals 6 plus 1.25x can be used to find the cost of joining an online music club and buying X songs from the website. Based on this information, which statement from the graph of the situation is true? All right, I really want to compare this equation they've given me to the equation I know well. The equation of a line that I know well is y equals mx plus b. All right, the y here is called the dependent variable, the depth var. M is called a slope. X is called the independent variable. And b is called a y-intercept. Now, if I write this equation that they've given me here, it's the same thing. Okay? I'll write this as y equals 6 plus 1.25x. Now, if I write it in this form, I'll have y equals, because that's what I have, y equals mx. There's a number times x. This number is 1.25 times x. So it's 1.25 times x plus some other number. That's plus what? 6. So I'm going to write it this way. Okay. Your y is your dependent variable. And what is your dependent variable? What does y mean? This equation is used to find what? To find the cost. This is the same thing as your y. So this here is your cost. This is your slope, which is your rate of change. Two things are changing, x and y. Okay, let's actually figure out x here first. X is an independent variable. Online music club buying how many songs? X songs. So x is the number of songs. So this is songs. This is a slope, the rate of change of y and x. And this is the price per song. Per song. So what I'm telling you here is that the slope is what? The price per song. That's what the slope means. The y-intercept, of course, is the what? It's going to be some sort of fee that's tacked on to using this. Okay? It's actually the cost of joining an online music club. They're charging you $1.25 per song and then plus $6 to join. This is the cost to join, sorry. Alright, so let's figure out what all this means. The y-intercept of the graph represents the cost of the song. No, what does the y-intercept mean? The y-intercept is this number, and this number is what? The cost to join. So no, that's not true. The cost of each song is actually what? The cost of each song is called the slope. So this is wrong. The y-intercept of the graph represents the cost of joining the music club. The cost to join the music club is this number, and this number is in fact the what? The y-intercept. That is true. Okay? It costs you $6 to join the music club, and then what? You get charged $1.25 per song. This lone number, though, is the cost of actually joining the club. This is actually correct. Okay? Let's go through the other answers. The slope of the graph represents the total number of songs bought by the members. X is the total number of songs. What is X? X is an independent variable. It is not a slope. Slope is a number, which is what? The price per song. So the slope of the graph represents the price per song, not the total number of songs. This is wrong. Remember, the slope represents the price per song. It says the slope represents the number of songs. That's not true. The slope is the price per song. We already know that. This is wrong as well. So your answer for this one is G. This is basically, do you know your sense around the word problem here? All right. Oops. I need to go back here. Skipping a question. Scroll down. Okay. I'm quite fond of these questions. And the reason is they're giving you 5 figures in a pattern below, and each figure is made up of identical circles. So there's lots of circles here. If the pattern continues, which expression can be used to find the number of circles that make up figure n? So n, they're calling figure n. This figure is 1. So they're telling you n right here, this n value is 1. Okay? This n value here is what? Is 2. This n value is 3. N value is 4. And this n value is 5. All right. Okie doke. So let's take a look at this. I'm going to make a table here. I'm going to have n. And then I'm going to have number of circles. These are going to tell me the number of circles, these expressions. So let's take a look at figure 1. If I have 1 for n, how many circles do I have? 1, 2, 3. All right. If I have n is 2, then I have 1, 2, 3, 4, 5, 6, 7, 8. So n is 2, number of circles is 8. If n is 3, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 3, 15, and so forth. All right, so we don't have to do the whole thing, but let's take a look at these answers. If I have this expression here, I'm telling you n squared plus 2n. Okay, so I got some number squared plus 2 times another number. And what is n for this value? Let's say n is 1. So I'm going to plug in 1 for these n's right here. What is 1 squared? That's 1. What is 2 times 1? That's 2. What is 1 plus 2? That's 3. Does this number match this number? The answer is sure. Now we're going to do this again. We're going to change this number. Okay, this number here, we're going to change it to a 2. So 2 squared plus 2 times n. All right, 2 squared is 4. Oh, wait, what is n? N is 2, we're saying, so this is 2 times 2. So 2 squared is 4 plus 2 times 2, which is also 4. 4 plus 4 is what? 8. Does this number match this one? The answer is yes. Let's try this one more time. 3 squared plus 2 times 3. We're just substituting 3 in for these n's right here. This is going to be 3 times 3, which is 9, plus 2 times 3, which is 6. 9 plus 6 is 15. Does this number match this one? The answer is yes. So this actual solution is in fact A. Okay, it can't be any of these other ones just based on looking at it. Okay, if I plug in 2 for this equation, this is 2 squared plus 4. That's what? 4 plus 2, which is 6. Is this a 6 right here? The answer is no. We can keep doing this for the rest of them, but you're going to find that none of them actually work except for A. So let's go on to the next question. All right, number 6. One wall inside a shoe store is used to display walking shoes and running shoes. We have 2 types of shoes. We have walking shoes and we have running shoes. All right, there are 135 pairs of shoes in this display. So W is the number of walking shoes I have. R is the number of running shoes. So I'm going to take all my walking shoes, add all of my running shoes, and how many shoes do I have on the display? A total of 135. So all the running plus all the walking equals 135. I've created an equation. There are 1.5 times as many pairs of walking shoes as there are running shoes. So the walking shoes is the same thing as the running shoes times 1.5. That means there's 1.5 times as many walking shoes as running shoes. To find that, we multiply R, the number of running shoes, by 1.5, and that's the number of walking shoes. What I've created here is 2 equations. In an algebra, 2 equations is referred to as a system. Okay? The great thing about systems is that you can solve them in a calculator. The calculator command for the inspire is menu 3, 2. So let's check out the inspire, and we're going to plug in these two equations in here. Okay, so this is 1.5. All right, so let's go. Okay, so we're back to our calculator here, and what I'm going to do is go to menu, algebra, solve system of equations. There are two equations. My variables are w and r. It says x and y, so I'm going to delete these and change them to w and r. So I'm going to hit w, comma, r, and then hit OK. Now the first equation I gave you was that all the walking shoes plus all of the running shoes equals 135. So I'll put that in there. W plus R equals 135. The second equation that I wrote down says that W is equal to 1.5 times R. So times R. Now when I hit enter, it's going to tell me W and R, the number of walking shoes and the number of running shoes. So as it turns out, the number of walking shoes is 81 and the number of running shoes is 54. So let's go to the answer. 81 pairs of walking shoes and 54 pairs of running shoes. That's what the calculator told me. There are no other answers that come close to that, so the answer is J. The calculator did this pretty much for you, except you have to create a system first and then solve it. This is actually an intermediate to difficult question. This is not easy to do for a lot of students, is creating this system, but with practice you can get better at it. Alright, so here we got this. We have, I need to zoom out of this one. This one's going to be kind of interesting. Alright, so the mapping below represents a quadratic function. Remember, a quadratic function makes a parabola. Alright, so I'm going to make a table with this quadratic function. I don't like function maps because they're not easy for me to read, so I usually convert them to a table. So I have -2 in this x, and this is pointing to what? To -3. So that's the y value that it goes with. -1, 0, and 2. Let's put it all down. -1 points to -3.75. This is negative, sorry. 3.75. 0 points to -4. And 2 points to -3 again. As you notice here, the y value repeats, but that's okay. Y is allowed to repeat. It is still a function. If you see x values repeating, that's a red flag. It's likely not going to be a function. But this one is so far. So which relationship shows the number of, well, which representation shows the same relationship between x and y? If I have a table that I've created, I really want to put it in a spreadsheet. That's what I'm going to do. Okay, this is the best way to go about this problem. So you have a calculator. We're going to put this table in a listing spreadsheet. Okay, so I'm going to get the calculator out, and it's going to be -2, -1. So what I do is go to a new document, open a new document, don't save, add a listing spreadsheet. I'm going to call this X. I'm going to call this column Y, and I start putting my numbers down. Okay, let's take a look at this. -2, -1, 0, 2. -2, -1, 0, 2. Put all my x values down from the table. Now we can insert the y values. These y values are -3, -3.75, -4, -3. Alright. So -3, -3.75, -4, and -3. They told me in the question that this is a quadratic function. It makes a parabola. Your calculator can model this as a quadratic function if you give it the right commands. So now that I have this table inserted, I'm going to go to Menu, Statistics, Stat Calculations, and I'm looking for one that says quadratic, and there it is. The question tells me it's quadratic, so this is what I'm going to select. Now it's going to ask me, what did you call your X list? Okay, I called my X list X. Okay, that's what I labeled it on top. So if I hit the drop down, there it is waiting for me. It's already stored. The Y list is Y, and I'm going to store this regression into the function f1. And then I hit OK. What it actually does is gives me the A, B, and C terms of a standard form equation for a quadratic, which we learned in class. But I actually want to make a table so I can compare it to the other answers. So I need to graph this, even though I have all this information. So to make a graph of this, I'm going to hit Control Doc, and I'm going to add a graph. What you should notice right away is that it says F2 on your command line. Okay, I stored the function into F1, so to make it show up, I hit the up arrow on the calculator. It's already stored from the regression I created, so I hit Enter, and it'll actually graph it for me. Now, the reason I make the calculator do it this way instead of just going into a data and plotting the points that way is because I can create a table now. So what I'm going to do here is hit Control T and make a table. I am now going to compare this table with the answers and see which one matches. Okay, so let's take a look at your question again. This first answer matches -3 with 1.75. Does my calculator do that? So from here I'm going to go up to -3. And -3 goes with -1.75. Okay, so that's a -1.75. But this one here is actually a positive 1.75. So the signs are wrong. So this is actually not correct. This answer is bad. Okay, so now we're going to check this. Does this graph look like my graph? I really want to zoom in on that one. Okay, does this graph look like my graph? This graph crosses the y-axis at -4. I notice that's where the vertex is. So let's take a look at my graph. Let's just see if it compares at all. My graph also crosses at -4. Okay, my graph has x-intercepts at right here, which is -4, and this one at +4. Does theirs do that? No, theirs crosses at -2 and +2, crosses at -4 and +4. So this isn't the same. So this answer is also wrong. Okay, so we got rid of 2 answers. Now I'm going to look at this answer. Let's compare -4. On my table, -4 should pair up with -6 if this answer is correct. So let's try that. So I'm going to go up to -4. This -4 does not pair up with -6. This actually doesn't mean -6, so this is actually wrong. So this answer's got to be wrong. Since this order pair is not in my table on the calculator, this thing can't be right. The only answer that's left is D. Alright, and as a matter of fact, if you graph this equation onto the calculator, which is what, -0.25x squared minus 4, and I'll do that, it'll basically lay right on top of the graph I already have. So I'm going to get rid of this table, and I'm going to graph the function they gave me. That function they gave me actually matches the function I have. Let's go ahead and do another graph though. Hit Tab. I'm going to graph that function they gave me for that answer. So 0.025 x squared minus 4. If this answer is correct for part D, then I should see just a different graph on the same thing. Okay, let's take a look at that. Oh, I made a mistake. I put an extra 0 in there. Let's try that. Okay, as you can see, it lays right on top of that graph. This is actually matching the same graph I already had. So this is actually the correct answer. It matches the exact same graph. So we'll select the answer D. Long-winded explanation, but this is how we're eliminating all of our answers. Okay, let's take a look at the next question, number 8 here. The slope of a line that passes through the points -1 in W and -10 in 4 is 1/8. What is the value of W? I suggest you use a calculator. This is a calculator problem. Okay, so basically when they give you 2 points, you should put this in a listed spreadsheet. So you have 2 points here. If you're writing it as an X and Y table, then your X values are -6 and -10. Your Y values, we're not going to say W. I don't really know what W is, and this other one's going to be 4. This unknown value for W, what we're going to substitute for that are these answers. We're going to plug these in for your W one by one. So let's try this, and we're going to try to get a slope for this line that's equal to 1/8 by substituting these values. All right, so let's open up a calculator. Okay, from here I'm going to create a new document. Don't save, and I'm going to add a list in the spreadsheet. So I'm going to label this my X and label this my Y. Let's take a peek at these values again. So I need -6 and -10. All right. Okay, so I need -6, -10. And here I'm going to need 4. So it's this right here that I'm going to start substituting values. So I'm going to go check my first answer here. It says F is 36. So I'm going to substitute 36 into this table. I'm going to put this in here. This is going to be my W value for the time being. And then I'm going to create the equation of this line using the calculator. And then I'm going to check the slope of this equation it creates, and hopefully it's going to be 1/8, which is what I want it to be. So I'm going to go to Menu, Statistics, Stat Calculations, and you're looking for line, linear regression, mx plus b right here. So I select this, my X list. I'm going to click the drop down. I called that X. That's what I labeled the column. The Y list, I labeled that column Y, and I'll save this regression into F1, and I hit OK. It tells me that the slope of this line, if this value is 36, will be 8. Okay. Keep in mind though that this is not supposed to be 8. It's supposed to be 1/8. So this answer is wrong. Okay. This gave me the wrong slope. So this one's wrong. I'm going to cross this out. So now I have to try 34. So I go back to the calculator. And I'm going to go back to this value here. And I'm going to substitute 34 instead of 36. Go back to this value here. And I'm just going to type in 34. Instead of 36. When I hit enter, it actually changes the slope. All right, it changes it to 7.5. 7.5 is way bigger than 1/8, so this answer is also wrong. All right. Okay, now they want me to try H, 9/2, so we'll substitute that. So I click over here and I just hit 9 divided by 2, just like it says. What this gives me is a decimal answer that's less than 1. So they say the slope here is 0.125. Now I'm not really sure what 0.125 is as a fraction, and because my slope is a fraction, it's 1/8 in the question. So I can make the calculator tell me what that is. I'm just going to go over to the scratch pad right here, and I'm going to type in 0.125, which is the slope it gave me, and I want to approximate this to a fraction. So I can go to Menu, Number, approximate the fraction, and then hit enter. Hey, what do you know? 0.125 is actually the same thing as an eighth. And the eighth, as you recall, is what I wanted. I wanted this to be an eighth. So this is actually the answer for W. If I plug this into W, I'll get the slope that's required. So this is the answer. It's H. Okay? This is all calculator work right here. It's just calculator play. So don't worry about actually doing a whole lot more than that. Let's go on to the next question with this. All right, number 9. Let's make this wider so I can see it. All right. So this is a question here. Actually, I can't see that too well. This is a question here about population of Webb County, Texas from the year 2000 to 2010. And what's happening here is the population is increasing. And this is the number of years since 2000. So 0 right here represents the year 2000. This will be 2002, 2004, 2006, and so on. All right, so the question that they're asking me, if this trend continues on the graph, what would the population of Webb County be in 2015? As you can see, this stops here at 2012. It doesn't go to 2015. So that means I'm going to have to extend this data. This is called extrapolation. I'm going to take this trend line and I'm going to keep it going. Since it's linear, I'm going to keep it going further. All right, so this is going to be 2012, there'll be a 2014, and a 2016, and then somewhere in the middle there'll be a 2015 out here. Okay, so what I'm going to have to do is kind of guess what the population will be at that time. So I'm going to say 2015 is right about, yeah, it's actually about here. And they want me to guess. So if I take this data and extrapolate it and make a guess, my guess is going to be about 275,000 people. That's just a guess, and I'll see what the closest answer to that is, because my guess could be off. The closest answer, 275, there's actually only one reasonable answer. It's going to be about 278,500. All right, so it's pretty obvious this has to be the answer. None of these are even really close. So that will be your solution. It's really just an estimate, okay? Don't spend a whole lot of time on that. All right, number 10. This is a wordy problem, but let's take the time. It's not that much work here. So we're going to say a city employee paints curbs in parking lots and replaces road signs. Okay, it takes half an hour to paint a parking lot, a curb, and 2.5 hours to replace a road sign. The function below can be used to find C, the number of parking lot curbs the employee paints when he replaces R road signs. Okay, so they're telling me basically C is the number of curbs. And R is the number of road signs. It's important that you understand that. That's all. That's all you're getting out of this, really. The employee painted 20 curbs a week. So 20 here is the number of what? It's the number of curbs. It gave you the value of C. So I'm going to substitute 20 into C. And then I'm going to rewrite this equation. But the only thing they can really make you do now is figure out the unknown value of R. And of course, what are they going to ask you? How many road signs? The number of road signs is R. They want you to find R. This is a single equation, so this is a calculator. Use a calculator. Single equation solving for a single variable. That is a menu 3-1. This is an insolve that we're going to use in the calculator. So let's go ahead and get the calculator out. All right, so I have my calculator. I'm going to add a calculator. I'm going to go to menu 3, and then 1 is the numerical solve. And then we'll type in our equation. So let's take a look at that. Take another peek here at the question. So it's 20 equals a fraction. All right, so 20 equals 40 minus 2.5R over 0.5. All right. So on the calculator here, so in my calculator, I'm going to say 20 equals, and then there's a fraction. To make a nice fraction in the calculator, you'll hit Control Divide. So that's what you should do on your test. Every time you make a fraction there. So this is going to equal, what does this say here? 40 minus 2.5. All right. So I'll say 40 minus 2.5 R, and on the bottom I had 0.5. I want to solve this equation for R, and you must tell the calculator that. The calculator doesn't know what you want it to solve for. So you'll hit comma R. This tells the calculator to solve this equation for R. You hit enter and it tells you R is 12. All right. So you look at your answers. Is 12 an answer? Well, sure is by the looks of things. So this answer is J. And then you move on. Don't spend too much time. This reading part, it can get you bogged down. It takes up time, and students, you know, some of them are in a hurry and they get worried. But take your time. You have plenty of it. Number 12, a rectangular prism has a width of x inches, a length of x squared y inches, and a height of y squared inches. This is actually only complex because you have to know what a rectangular prism is. It's a three-dimensional solid. Okay, you draw a rectangle. And then I'm going to kind of try to draw a box or a rectangle shaped box, which is called the rectangular prism. And there are three dimensions to this. There's a length, a width, and a height. They tell me that the width of this is x inches, so I'm going to make this little side here x right here. The length is x squared y. And of course the height, they tell me, is y squared. So this distance is y squared. They say which expression represents the volume. If you remember the volume of a three-dimensional rectangular prism, we have a volume is equal to all these dimensions multiplied by each other. Length times width times height. So what they really want you to find is this times this times this. Okay? There's not a whole lot of easy ways to do this. with the calculator unless you want to get creative with substituting values into x and y. But to be perfectly honest with you, this is really one you should be able to tackle without using a calculator. So v, we're going to multiply the x's here. So I'm going to look at the exponents. This x has a power of 2, this x has a power of 1. When you multiply the x's, you add the powers. So 2 plus 1 is 3. So this will be x to the power of 3. And I've used these all up. Now this y has a power of 1, and I'm multiplying y by y. So y times y, add the exponents, 2 plus 1. So this will be y cubed. This is your volume. This is the answer. That's about it. Okay, skip down to number 13 here. The graph of line T is shown on the grid. So this is a line called T. The line W, so they're talking about a second line that we actually can't see. They're going to make one, is steeper than line T and has a y-intercept that is below the y-intercept of line T. Well, what's the y-intercept of line T? All right, because I want to figure out which equation represents line W, the new line, and this new line has a y-intercept that is less than the intercept of yt. The intercept of yt, where it crosses the y-axis, is right here, and this value is 2. Okay, so here's the y-intercept of t, and they're saying it's 2. This new y-intercept will be below the y-intercept of t, so this y-intercept has to be less than 2 for the new one. If you recall, lines are written in this form, mx plus b, very typically. This is the slope, and this is the y-intercept right here, this number by itself. It's called a y-intercept. It's not multiplied or by anything here. This y-intercept in this case is 2, and I need a number that's less than 2 for the new y-intercept. So let's check out the answers. These numbers here on the end are y-intercepts, all of them. Which one of these are less than 2? Quite obviously, these two values of 4 are not less than 2. Okay, so only -1 is less than 2, and so is this other one. So you've eliminated half your answers just by knowing that little fact. Now you can make an educated guess if you had to, but we're not big on guessing. The only thing different between these two equations here is the slope. You have this slope and this slope. And what they've told me is that line W is steeper than line T. Let's actually figure out the slope of line T. Alright, and this is going to be a little tricky, but I'm pretty sure we can manage it here just by kind of eyeballing it. If I say the x-intercept here is 5, 0, then I'm going to go from here to here. So I'm going to go down 2 and over 5. So I'm going to actually say the slope of this is -2/5. Alright, that's not very steep actually. And we have to find out a fraction that's bigger than 2/5. Okay? So here's the real question. Which fraction, if I ignore the sign here, if I ignore this negative, ignore this negative, which fraction, 2/3 or 1/4, is actually bigger than 2/5? Okay? As it turns out, 2/5 is actually bigger than 1/4, so this can't be possible. This is actually shallower, so I'm going to get rid of this knowing that. So this answer is correct because 2/3 is in fact a bigger number than 2/5, and therefore it'll be steeper. So your answer is A for this one. Oh, let's scroll down. Let's do this one here. A griddable question. Okay, remember I suggest that you do these first. A senior employee who works 16 hours earns $39.50 more than a junior employee who works 18 hours. Okay, senior employee earns $14 per hour. What is the hourly pay in dollars and cents for the junior employee? Okay, so what we're going to have to do is basically set up an equation here. Read this carefully and see if we can write an equation. This is actually pretty challenging in comparison to several other problems. So we say senior employee works 16 hours and earns $39.50 more than a junior employee who works 18 hours. So you got two types of pay. You got senior pay and you got junior pay. All right. So the senior pay, this is the pay per hour, by the way. This is senior pay per hour, and this is junior pay per hour. All right. So the senior works 16 hours, so it's going to be 16 times the senior pay per hour. All right. This amount is going to be $39.50 more. So this equals $39.50 more, which means they're adding $39.50 to something. Okay? $39.50 to what? The junior employee's pay if he works 18 hours. So it's $39.50 more than 18 times the junior pay per hour. So this junior employee works 18 hours, and then this is his total pay for 18 hours. If you add $39.50, it's the same thing as the senior's pay for 16 hours. Okay, the senior employee. So what is the hourly pay in dollars and cents for the junior employee? All right, we need information here to solve that, and here's what they're telling you. The senior employee earns actually $14 an hour. So what they're actually giving you is the value of S right here, which is nice of them. So this value of S is at 14. So it's 16 times 14, and this will equal 18J plus 39.50. So basically we have a single equation. We can solve this with a calculator now, and it'll be an solve. It's called menu 3-1. So solve this equation, and we're looking for the only thing we don't know, which is the pay of the junior employee. And that's what they're asking for. What is the junior employee's pay? So let's go ahead and type this equation to a calculator and solve it. Alright, so we're going to go to menu 3-1. So it's 16 hours times the senior pay of $14 an hour. This will equal 18 hours times J. Remember, J is the junior employee's pay. And then we're going to add $39.50. That's what the equation tells me to do. Now you have to tell the calculator what do you want to solve for. What I don't know is J. That's what I want to find. So tell the calculator solve for J, comma J. If you don't do this, it doesn't know what you want. So I hit enter. Apparently the junior employee's pay per hour is $10.25. So that's your solution for this question. Okay, so in this particular problem, what we're going to have to do is grid in 10.25 into your griddable, your bubble sheet there. So do that and give it a shot there. Okay, number 15, in 3 different workouts, a run and burn 300 calories in 30 minutes, 350 calories in 35 minutes, and 200 calories in 20 minutes. Based on the data, which statement is true about the number of calories burned as a function of the number of minutes worked out? Okay. All right, well, what they're telling me then is the number of calories burned is a function of the number of minutes the runner has worked out. Okay. So calories burned is your Y, because that's what it's a function of. So we're going to say Y is calories burned. And this is equal to some unknown value, maybe, okay, times the independent variable here, which you're saying is a function of what? The number of minutes the runner's worked out. So you have 2 variables, the dependent, which is Y, and the independent, which is X. And the calories burned is a function of the minutes. So what I'm telling you is that X here means minutes, and Y here means calories burned. Y is a function of X, and what? Calories burned is a function of number of minutes. So that tells you that calories burned is Y, and number of minutes is X. Okay? So we have an independent quantity, which is minutes, and a dependent quantity, this is dependent, which is calories burned. So let's check these answers. The number of minutes the runner worked out is the dependent quantity. No, the number of minutes worked out is the independent quantity. I told you this isn't true. It's not dependent, it's independent. So this answer is wrong. The number of workouts the runner completed is the dependent quantity. No, what's the dependent quantity? It's the number of calories burned. It's not the number of workouts. Okay, so this one's also wrong. The number of calories burned is the dependent quantity. Yes, the number of calories burned here is the dependent quantity. We just said that. That is true. This last one, the number of steps the runner takes. No, there's 2 things we're comparing, minutes and calories. It mentions nothing about the number of steps. So this doesn't even matter. This doesn't make any sense. It's not even part of our question here. So your answer is C. All right. So let's go down to number 16. As you can see, these are actually non-calculator problems that you're going to have to reason through. You can't use a calculator in every question, but it's very useful for many of them. Here they're asking about a range of this function graphed. Alright, so here's what I'm going to say. Do you know what a range is? Okay, a range is a set of Y values. Okay, if I have a set of X values, this is referred to as a domain. So they're asking about Y values. So your answer should only have Y's in them. This has an X in it. It's not a Y value, Range is a y value. This has an x, so it has nothing to do with range. This is wrong. Okay, this is a y, so this is possible. This is an x, so it's wrong. Only y values are range values. So this is a y, so this is possible. So simply knowing the difference between domain of range and x and y, we can get rid of two answers right away, knowing that range is in fact a y value and not an x value, and anything with x in it has to be wrong. So now I take a look at this graph, and we have to find the allowable y values. So I'm going to look at the lowest point on the graph and trace it to the y-axis, which is -3. And then I go up to the highest point of the graph and see the y value is 4. And then there's a steady graph all the way in between them that can trace back to all these values. There is actually no break in the graph whatsoever. Alright, so what I'm going to say then is that you have a minimum value and a maximum value. So the minimum value is 3, the maximum value is 4, and all the values in between them, between -3 and 4, are values of y. Alright, now you always have the inequality arrows, and which way do they point? To the left, everything you own in the box to the left. Even Beyonce knows her mathematics here, right? They always point to the left. If I don't see an open circle here, that means that -3 is part of the range, so I have to put n equals. Y could equal -3 because that's a closed circle. It's also a closed circle up here at 4, so I'm going to put an equal sign there. This is your solution. It's -3, 4, and all values in between them. This answer is G, and that's moving on there. Alrighty, this is also a non-calculator question, and I'm going to tell you why here. It says points 3, 2, and 7, 2 are on the graphs of both quadratic functions f and g. The graph of f opens downward and the graph of g opens upward. Which statement is true? Okay, here's the problem. They tell you it's a quadratic function, but to graph a quadratic function, usually you're tempted, if you see points, to put them in a spreadsheet. But in actuality, the calculator requires 3 points to graph a quadratic function, and you only have 2, so you really can't use a calculator, and that's pretty tricky. So what I'm going to do is try to plot these points here myself. So let's do a little grid here, a little sketch, and you actually get graph paper on your test, so you may want to use it. You can tear it out of the front there. I know how to plot these points. Set 3 and 2. So I'm going to go over 1, 2, 3, and then up 1, 2. So I'm going to say there's a point right there. And then 7 and 2. So I'm going to go over 1, 2, 3, 4, 5, 6, 7, and go up 2 as well. All right. These points are on both functions. But one of them is opening downward, which is f, and the other one is opening upward. So f is opening downward. It's a parabola. It's a quadratic. So it's opening like this. It's opening downward, and it's doing this. Okay, so this is the function f. You got another function here that's opening upward, and that's g. So you got something that's doing this, pretty much. And this function is called g over here. All right. So let's see if we can figure out these questions. The graphs of f and g have the same axis of symmetry. When you make a parabola, the axis of symmetry will split the parabola in half right down the middle, so symmetrical across both sides. As it turns out, this is true because they share the same 2 points. They have to share the axis of symmetry. That is correct. This axis of symmetry cuts both of them through the middle. The graph of f and g have the same x-intercepts. So they're asking you where it crosses the x-axis. Is it the same spot? Well, no. F crosses the x-intercept right here, and g crosses the x-axis right here. These 2 points are not the same. So no, they don't have the same 2 x-intercepts. This is not true. The graphs of f has a maximum point, and the graph of g has a minimum point. So here's f, this one right here. It does have a maximum point. This point is called the maximum point, and that is true for f. G does in fact have a minimum point where it doesn't go any lower than that, so that is true. That's actually correct here. And then right here, the graph of f is a result of a reflection of g across the x-axis. That's not necessarily true because that really depends on how wide this graph is. This graph could be pretty wide. I could actually have a graph that looks like this and goes through these as well. So it's not actually true, not necessarily true to say that. So no. So your only real definitely true answers are 1 and 3. So not 1 only, not 2 only, not 2 and 4, but 1 and 3 is actually what you're looking for. And then we'll try to move on from that. So this is a non-calculator question that you're going to have to reason through. Read very carefully, take your time, do the best you can. That's really the only thing that can be told. Draw a diagram and try to figure it out. Okay, a scientist needs to print a research report on her computer's printer. If she prints in black ink only, they charge her this. Okay, so this equation here for black ink, which is why they're using B, describes the number of pages left to print. So this is a number of pages left to print right here. Okay, after T minutes. So they're telling you T right here is time. So after you spend a number of time, okay, this is the number of pages you have left. If she used color ink, they give you another equation, C for color, and this is time again. This represents the number of pages left for the color ink, okay? So this describes the pages left after T minutes. Which of these statements is true, all right? The printer prints 3 more pages per minute in colored ink than in black ink. It's telling you right here, this is the number of pages per minute it's printing, okay? So you take the total number of pages you started with, 152 pages that haven't been printed, and then you're going to start printing them, apparently at 33 pages per unit of time, or per minute. So 33 pages per minute, and then after you subtract what you printed, this is what you have left, that you have pages left that haven't printed. So black ink prints 33 pages per minute. Colored ink prints 30 pages per minute, all right? So as it turns out, black ink prints 3 pages more per minute than colored ink does. This answer says the printer prints 3 more pages in colored ink than black ink. That's not true. Colored ink prints 3 pages less than black ink, not more, okay? So colored ink isn't faster, so you have to be careful with how you're reading that. This is not true. The printer prints 3 fewer pages in colored ink than black ink. That's true. Colored ink prints 30 pages per minute. Black ink prints 33 pages a minute. So colored is 3 fewer than the black ink. So we say colored ink compared to black ink is in fact 3 fewer. This is correct. Okay. The printer prints. Let's just keep checking all the rest of the answers. The printer prints the same number of pages per minute for either type of ink. No, these are not the same speed per minute. It's 30 per minute and 33. This is not true. The printer prints the entire research report in 152 minutes. Well, yeah. Is that true or not? Well, basically they want you to substitute 152 in for T here, and you could do that, but that's not really going to make a whole lot of sense to do that because we know this answer is G. You could do that in a calculator. You would actually see that's probably not true for at least one of them. So there you go. So they're telling you this takes 152 minutes exactly. That doesn't make sense because if I plug in 152, you're going to be able to print way more pages than that. Okay, it's not going to take 152 minutes to print the report. It's going to take far less than that. It doesn't make sense for either colored or black ink. So this answer is not really what we're looking for. Number 19. Which expression is equivalent to this? Okay, so they want you to simplify this and get this. This you could do by hand, okay, but it takes a little bit of algebra skills with fractions and things. If you're intimidated by this question, there is a calculator technique you can use to work around it. So I'm going to show you that, and I'll go ahead and work it out by hand over here too. So I'm going to do this by hand, and I'll show you the calculator technique. So let's do the calculator technique first, okay? So this is the one I recommend you try to do this problem. I have to simplify this and see if it's one of these, okay? I don't really want to do that by myself without any help, so I'm going to use the calculator. All I have to do really is store a value into this variable m, since that's what we have. I suggest an odd number, so I will store 3 into the variable m. And I'll go ahead and do that. So I'm going to make the calculator do that. So store the calculator value 3 into m. So to do that, to store a value into a variable, you hit the value that you want. So I say 3, and then I come over here, hit Control, and then var above the 9, and there it is. And then I hit M, and it says, okay, store 3 in M. Now your calculator thinks M, which is now bolded, is the same thing as 3. So now I'm just going to type in the question. I'm going to copy this exact equation. 2M plus 3 halves m plus 1. Just copy this entire thing, okay? Just copy this entire thing right here. (2m). All right, so 2m times, open parentheses, make a fraction, control divide. Okay, we want 3 halves. Nope, 3 halves times m plus 1 close parentheses plus 3 times, open parentheses, 5/3 m minus 2. Very well. So I hit control divide, and then 5/3 m minus 2. And then I hit enter. It gives me the number 42. Now all I'm going to do literally is type in all the answers until I see the number 42. When that happens, that'll be the correct answer. So let's look at the first answer. It says it's 3m squared plus 5m minus 1. That's the answer A. So 3m squared plus 5m minus 1. Three m squared, oops, good gosh, 3m squared plus 5m minus 1. That gives me the answer 41. I'm looking for the answer 42, so this answer is wrong. I can cross it out now. So then I'll try the next one. I'm going to keep doing this until I see the answer 42. So 3/4 m squared plus 2/3, plus 23/9m minus 6. Alright, so make a fraction again, control divide, 3/4 times m squared plus, what is this again? 23/9m minus 6. So make another fraction, plus 23/9 times m, and then minus 6. This answer is not 42. Something awful here, 101/12. So that one's wrong. We get down to answer C, 3m squared plus 7m minus 6. 3m squared plus 7m minus 6. One by one. This is 42, and that's what I was looking for to begin with. Here's the question, it gives me 42. Here's the answer that gives me 42, so I have the answer. And I didn't even have to solve it really by hand. So here's the answer. It's C, actually, and that will be the solution. Now, I promised you I'll do this by hand, so I'm going to do it over here. All right? So actually, I'm going to go ahead and erase this here. Let's get my eraser out. And I'm just going to do the whole thing by hand right here. All right. So when I have a number in front of a parentheses, I have to distribute this number. So I say hippity hoppity distributive property. So 2m times 3/2 m. What's going to happen with this 2 and this 2 are they're going to cancel. So I got m times 3m, which is now 3m squared. Now I have to multiply this 2m by 1. So 2m times 1 is 2m. All right. So I'm done with this part. Now I have to distribute this 3, hippity hoppity, distributive property. When I multiply 3 times this 3 here and this 3 here cancel. So what I really have here is just 5m. So this is plus 5m. And then I got 3 times -2, which is -6. All right, so how many m squares do I have? I have 3 of them. So I have 3m squared. I can add 2m to 5m because these are like terms. They both have m in them. So 5 plus 2 is 7m. And then minus 6. as you can see, this is actually the same thing as your answer. This is how you do it by hand. So whichever way you prefer, just please get the question right. That's all we ask, right? So, okay, number 20 is well worth looking at here. This is one of those griddable questions again. Okay, you see down here. Record your answer and fill in the bubbles in your answer document. All right. I've emphasized over and over again these sometimes are the easiest questions on the test. So please attempt these, and I actually recommend that you attempt them first again. Okay. So this one is giving you the equation of a line here. It says graph the equation in the form y equals mx plus b. It's shown on the grid. So they've given you a line, and they give you 2 points on the line here and here. If they give you 2 points, what they've actually given you is a table, okay? And then you could actually plot these points in a spreadsheet. You could put them in a spreadsheet, and you could actually recreate this graph in your calculator, okay? The question is, based on the graph, what is the value of x when y equals -7? If you could create this graph on a calculator, you could make an entire table for the graph, and then you could actually figure out where y is -7. You could figure out your unknown value from that table. There's nothing wrong with doing that, and it will give you the correct answer. However, that kind of undermines the point I'm trying to make, that these are very easy questions. All you really have to do to solve this question, okay, have a look here, is saying, what is the value of x when y is -7? You go to the y-axis, and you go all the way down to -7, which is right here. I'll trace this back to the graph, which is here, and they're asking me what is the value of x there. So I just trace up to the x-axis, and what do you see right here? This x value is in fact -5. That's your answer. Okay, this question, if you know what to look for, should only take you a few seconds. It's really not difficult, and it's, again, one of the easiest questions on the test. All right.